Hi, so my name is Siqi Lin. I'm a senior automation engineer at DSM Firmenich. So today's topic is I will walk you through our company's journey. Specifically from my side in US, New Jersey. And we're chemical manufacturing. So we produce ingredient for perfumeries. So the topic is from reactive to predictive, this is our maintenance journey. So let's begin. So here's just an agenda. First, we're going to talk about our company. Then we're going to talk about our maintenance practice evolutions. Then we dive into predictive maintenance use case that I did for our site. Then lastly, we're going to touch base a little bit about what's beyond maintenance, because my main job is actually automation engineering. So we do a lot of innovations in advanced control instead of in maintenance. So let's talk about our company. We're DSM Firmenich. We have over 30,000 employees across the world. So 60 countries that we have our facilities, and over 150 years innovations that we generate about like 12.8 billion of Europe each year. And there's like multiple manufacturing sites, application lab, and creativity centers. So this is all good figures, right? The footprint of our company. So what we actually do. So we bring progress to life. So we have 3 business units. One is perfumery, beauty, taste and texture, health, and health nutrition. So in perfumery beauty, we are actually #1 in that field. The way kind of produce the scents for the consumers, whether it's in the fragrance or in any like product cares, like any shampoos, body shower, anything that actually have scents, that we might be a player in there. So another part of business, taste and texture. Well, so beverage, powders, flavor powders, anything that's like tastes differently, or like artificial colors, textures, that we produce those as well. And you will see a lot in beverage that you have, especially like, maybe, for example, like orange juice, they always taste the same. It's not because the orange always tastes the same, because they all, sometimes they're bitter, sometimes they're not. And in order to like balance the taste and have a uniform taste, they actually add certain thing into it. So maybe that's what we do. So there's a lot of artificial things in there. Sorry, I don't want to do this, but yeah, this is the part of our business, right? Make it more pleasant to people and have, I love this product because it always tastes the same, Another part of business is health and nutrition. We do vitamin stuff. I think we're big in DHAs, in the formulas, like baby formulas. So the last business, why I say 3, because the last one we're gonna spin off. They're doing like animal nutrition, so we're gonna spin off like this year. Oh, so I am actually from the chemical manufacturer for perfumery and beauty. So what's our product, right? So a lot of times that we work with consumer, so they come to us, tell us, oh, I want to smell like winter. Yeah, really broad. And I was like, oh, okay. And then all the perfumers work together saying like, I want a winter. And then we have a lot of ingredients. So they mix together to produce winter they think they want. And they love it. So there's many like perfumes in here. Maybe you knew, like CK1s or Marnies. And a lot of things in the home care product, like shower shampoos, as you can see, detergents. So basically anything that need a sense, that's need to be like pleasant, then we are kind of involved. So you go walk into the supermarket, maybe anything that smell nice, it's maybe our product. Yeah, similar things in beauty and cares, because lady like something smell good. So usually you don't prefer anything stink to actually put on your face or your hair, right? So then that's what we do. And everything is based on our fragrance ingredient, that we have a world-class palette that the perfumers can work with and produce the pleasant smell. So let's dive into the real topic today. Actually, our journey of evolution of maintenance strategy in our site, particularly. So here is the timeline. I'm just gonna walk you through the journey. So back around 2000-ish, our maintenance strategy is always mostly reactive, like many of other company, that we just run the equipment until it fell, and then we fix it. And we did some periodically maintenance, right? So you do it, depends on the asset, you do it once a year, twice a year, or sometimes even once 2 years. And we know this approach is really introduce a lot of downtimes, and you do a lot of emergency repair. And for us, emergency repair means you lose $1 million a day, 2 days. So it's really critical for us. But then that's what we've been doing into around 2000. And we know there's no visibility of equipment health. We don't really care. We just run it until it breaks. So as we're moving towards the 2010s, we started changing our strategy, improve our strategy to install some like new technology, like vibrations technology for condition monitoring. And we began to improve the strategies, and we buy the vibration sensor from the contractor, and then we basically collect the data in-house and then send it back to them, and then they do the review, and then depends on the review, they would do maintenance around it. But this, this method kind of reduces a little bit downtime, but there's a lot of back and forth and time consuming. So in 2010, that we actually decide to bring in the specialists who work internally. So there's reduce these downtimes that have to do negotiate with outside. And he come up with plans and doing route-based condition monitoring, utilizing SKF. Call back to SKF. We're using their product, pretty good. With that, and then in 2014, we start to introduce something like wireless vibration sensor, that you have your vibrations in your hands in real time. Because with XKF, we have to still do manual data collections. So we want to have this faster. So we utilize another type of vibration technology to do the thing in real time. So this kind of running and keep us running and be kind of proactive to look into your machines or your asset. But what's the next step? So in 2019 and now, we start to kind of explore a route of advanced analytic around the condition monitoring and utilizing machine learning model to actually trying to predict if there's an issue with your asset or when your asset will encounter problems. So yeah, for this, I think condition monitoring was the game changers. So let me show you how we implement a route-based vibration analysis using SKF microlog. So here's just the flow lines of how we do the route-based vibration condition monitoring. So we utilize SKF microlog software. So the specialists have a certain way to download the routes for the data collection he want to do, and depends on asset, right? Maybe one time he would do multiple assets, so there's a route he take, and then he go to the site with this machine, device, I guess, collecting the data, and here the data will show you some information, but then he's just collecting and then putting it back to this software and do the analysis on it. And the specialists actually have to do the analysis themselves because every machine is kind of reacting differently. So he had to identify the patterns. So everything is a judgment call, basically. And you will have to be certified to do this vibration analysis. And once he did that, there's he generated reports, basically, and depends on the assets. If it's no good, that we do a work order, or we're utilizing SAP systems. So then, and then we do a repair, and the validation is the same thing. You collect data to make sure the asset is okay, and you close the work orders. So this is really a manual approach, but we're still using it. And we did that like every month as monthly inspections. So this is the way of proactively monitoring your machines. In 2014, we introduced a wireless vibration monitoring system. So we're utilizing MSM, we utilize the MSM machine learning wireless sensor. This provides a continuous monitoring of our vibration in real time. So it's kind of reduced a little bit on the manual data entry, manual data collection part of the job. So here's the outlook overview of this applications. So there's some information around vibrations, the waveforms or spectrums, but we know, like, it's not really a collective place to look at all your asset, because you have to click so many times and look at different trends. So what he did, our specialist did, is to integrate it to the data historian that we have. Here's a display of all the assets around the pump, and there is a pump trends and the information around them. So you see a lot of them is green, that means good. And if you see red, that's, it's kind of alert the specialist, maybe you have to do a manual inspections. And this, again, it's all judgment call based on the experience, right? The specialist experience. And up until now, everything is vibration based, nothing about process. So in 2019, we're realizing there's a lot of data, but we're not utilizing it. So we sit on a pile of data, like 10 years, 20 years, but nobody even looking at them. So this is what we are changing. We're actually kind of doing some data analysis in our operations. So we did the condition monitoring for the vacuum pump, like for example, just a vacuum pump. So what you do is we did like a real-time parameters checking. So this is continuous monitoring your parameters that around the assets that you want to know. And something like vent temperature, condenser temperature, cooling water temperatures, and pressure or reactor pressures and stuff like that. So it's overview of a trends for your process. And then based on the process, we do a performance metric. So basically some data analysis, right? Information about, like, how long it takes to get to the desired vacuum level. And there's a metric that we generate. So those things can use for monitoring. So if you start to degrading in your process, then it will bring attention to the engineers or the specialists. And we also do some anomaly detection. So if the current process is kind of deviate from your patterns, so we'll highlight it and kind of alert people. So it's all like data analysis so far in continuous monitoring. But taking it further step, we actually did predictive maintenance utilizing machine learning models. So here the idea is actually to improve maintenance planning and minimize operation downtime by forecasting when the pump needs the service. So we're leveraging a lot of historic data on operations and maintenance to develop machine learning models that can do that. So with the result of it, we generate some plots that can improve valve condition monitoring, and it's just better way of doing maintenance, reduce manual work for the specialists. And again, our specialists, we're only using one person. So when he's on vacation, nobody look at the machines, like, what are you gonna do? So that's why we go into more like a data-driven method instead of rely on one person. So here's a scheme of what we actually do. So this is a sketch of distillation reactions. So this is the input of data that we use. So reactor temperature, reactor pressures, cooling water temperature, vent temperature, data on maintenance for sure, and then the pump status and vibration sensor. So we're utilizing a tool called Seq is doing data analysis for us and do the dashboard. And they have a side product called Seq Data Lab. It's a Python environment, so they can doing machine learning model in there, and then we have the information, the result, and we push back to Seq to do the visualizations and the dashboards. So just a little bit detail about the modeling process and result. It's pretty simple. That you have all your information around the operations, then you do some cleansing, right? And then you do some exploratory data analysis, and we do a correlation metric and kind of remove anything that's more than 0.8, so reduce redundancy and simplify the models. And then you choose the model to put it in and try to predict when your pump needed attentions. So we utilize XGBoost. So I work with the data scientist because my background is not any of that. So they did a couple ones like linear regressions or random forest and XGBoost. So the accuracy of XGBoost is highest. So we're just utilizing that. And with the result of it, we generate a box plot that it will tell you the distribution of our features. For example, here is the vibrations sensor information that we have. So this tell us the distribution of this vibration sensor. So if you can observe from the plot, if it's between 0 and 5, maybe likely you have no issue with your pump, but if it's greater than 10, that maybe there's an issue you might want to check. So this is improving our condition monitoring. As a result of this machine learning models, we actually generate a binary graphic. So here it says -1 and 1. So -1 means no problems. And 1 just means that there might be an issue with your vacuum pump. And on the right-hand side is the same display, but just it's the same information, but it's in different display where you view it in Seq. It's the platform that we use. So it's more straightforward answers, yes or no. And we run these models every day at 7 a.m., analyzing the past informations. And based on the length of the yeses, that we will send out engineers or specialists to check on, do the manual inspections. So, and then with that information, we generate a dashboard and notification systems. So there's a real-time monitoring dashboards. It just tells you inside of how your pump's doing. Oh, is it okay today or not? And then there's number of counts of yeses. And if you have more than that, maybe you should start to check on your pump. And there's some key parameters, tracking metrics, and trending. Another thing is, with the result of the outcome for the prediction model, will generate automatically alarm systems. So it will just send you emails when there's issues with your pump or there's predictions about like, you might have issue with your pump, maybe look at it. So the specialist doesn't have to go on the dashboard to monitor anything. It's just waiting for the email to come to tell him, oh, maybe there's an issue you want to check. So with all this information, like, what's the result, right? So we've been running a short amount of times, like about 10 months. So there's automatically email generated in the same 10 months. And every time there's a flag saying, hey, you might to go out and check your pump, we send the specialist to do the manual inspections. And the validation part is like, is he finding anything that when the pump saying, hey, you have problems? Actually, we do see like 75 to 80% of alignments between the inspection data and the model result itself. So we do have confidence that this could be the thing that you predict when the pump likely to fail. So we might expand to more critical process. But in here, our field is like, when we have problems, it's not really safety concern, it's just downtime. And downtime means money. So you're losing money, but then there's no safety stuff. So we don't do 100% of validations. we just start to utilizing and see if we can have some value out of it, right? And I think there's another conference that I attend that was similar field, and they're using some kind of models, and the R value is like 0.03. And then the result is crazy. They were saying, oh, we was utilizing this thing with R03, and then still 0.3, they're still getting a lot of benefit out of it. So they save their production time like 30% just by that crappy data they have. So I think in our field, this approach is really convincing that we can start to utilizing, collect more data on it. And just conclusion of this, the condition monitoring and machine learning really play a big transformative role for our maintenance practice. And this entire goal is not to get rid of your specialists. It's actually to help them to reduce the time of their monitoring on the system that's not necessary to be monitored, to actually improve their work efficiency, I guess. And a lot of people are mentioned that people start to walk away, right? Now a lot of new people coming to the field, a lot of experience get lost in between. So what you do about that? You start to collect their informations and then utilizing this like data-driven method to improve, when the newcomers come in, there's a way to get to know the inside of your equipment, or they can utilize this machine learning result to actually do the maintenance when the specialist is not around or when this retire. And there's a future developments of all this. We're trying to look into the underlying cause of what's driving the vacuum pump, what's stretching out the vacuum pump itself. So trying to identify the root cause and utilizing some machine learning method, I hope. That, yeah, so beyond maintenance, so we're just gonna really run through really quickly. So my job is automation engineer, so we're using a lot of advanced control system here. So one of the key is the model predictive control systems. So it's like machine learning based predictive control systems that integrating with our autoclave systems that are dynamically changing the set point by the model itself, utilizing historical data. And with that we gain like 35% of process time with the particular product, and 35% could translate in $1 million. So with this simple approach, without any investment, because machine learning model uses like open source online. So minimal investments, you got a lot of outputs. Another technology is real-time in online molecular analysis. So there's a device that you can put it in your pipeline to detect the chemical concentration in real time. So then we're utilizing that to combine with the algorithm to control. So it's just like there's a supervisor behind running this all the time, and to maintain your process when there's an upset, instead of waiting for operators to do something. Sometimes it could be taking forever, and that's a downtime we don't want. So this is not only improving our yields, and it does significantly reduce the manual sampling, because a lot of time the operation need to go out and take sample every shift. So maybe every 6 hours they have to do it. So this end of our journey is like a just brief touch of my work. And thank you so much.